close down that whole smartboard because it was freezing and open a new one. So we lost the work for triangle A and B, but hopefully you have it on your paper already. Let's check triangle C. So first C, what we had done so far is we'd written the formula for area of a triangle, which was 1/2, and then we were calculating our base and our height. So when we count the units in our base, we see 1, 2, 3, 4, 5, 6. So 1/2 times 6. And the units in our height, remember it's not the diagonal, it's the line at a right angle to the base. So I have 1, 2, 3, 4 units in my height, which is 1/2 times 24. Half of 24 is going to be 12 units squared. So my answer to C should be 12. Question 3. Here's a right triangle, meaning it has one right angle denoted by this square. Name a corresponding height for each base. So what this question is asking is for each base that I have, side D, side E, and side F, we need to figure out, well, what is the height that goes along with that base? So A, if I look at side D, I need to pick a dotted line that is at a right angle from D. So it should come down like this, being at a right angle. The only dotted line that is at a right angle from D is G. So my answer to side D is going to be G. So we're going to put a G next to it. Then I'm going to look at side E. For E, I need to find a line that goes at a right angle and goes the whole height of the triangle. So if my base is E, my height is actually going to be F. So let's write F. Look at part C, see if you can do that on your own. So if side F is my base, the line that's at a right angle to side F is going to be E. Okay, question 4. Find the area of the shaded triangle. Show your reasoning. I actually want you to pause the video and try number 4 completely on your own. Look up when you're done. All we have to do for this is pick a base and find a height. I'm going to go with a base of 6. So I'm going to say over here, area equals, I know I have to have my 1/2 because it's a triangle. Base is going to be 6. So I'm going to say 1/2 times 6. Now I just have to figure out, well, what is my height? My height line needs to be at a right angle and go the whole height of my triangle, like this. But they don't give me that line. They do give me a line that's identical to that. So looking at my measurements that I have, I see this side of my square 6 is at a right angle right here to my base and goes the whole length of the triangle. So I know that I can plug that in here. So I'm left with area equals 1/2 times 6 times 6. 6 times 6 is 36. Divided by 2, area is going to equal 18. 18 units squared. 5. DeAndre drew a line connecting two opposite corners of a parallelogram. Select all true statements about the triangles created by the line that Andre drew. Once again, I want you to pause and try this one on your own. Press play when you're ready to review. So A says each triangle has two sides that are 3 units long. So I'm looking at my triangles here. I see that this is 3 units long, so I'm going to go ahead and label it. And I see that this is 3 units long, but these sides are clearly more than 3 units long. So does each triangle have 2 sides that are 3 units? No, they only have 1 side that's 3 units long. So we are going to cross out A. Each triangle has a side that is the same length as the diagonal line. So the diagonal line, I'm going to highlight it, is right here, the one that's separating the two. Is that a length of the triangles? Yeah, that is one of the sides of the triangles. So B is correct. Each triangle has 1 side that is 3 units long. We already discussed that in response to A, so C is correct. D, when one triangle is placed on top of the other and their sides are aligned, we will see that one triangle is larger than the other. Looking at these two triangles, if this is the same length and their base is both 3, what we can do to see if they're exactly the same is we can see if they have the exact same height. So to do that, we're going to draw a line that is at a right angle to the base. Here's my height line. Draw it with me. Then let's see if it's the same. We're going to count the units. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to write on my height line 9. Now, does the other triangle have a height of 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So if their bases and their heights are the same, guys, these have the exact same area. So is one larger than the other if they have the exact same area? No. The two triangles have the same area as each other. Yeah, we just figured that out. Let's go ahead and write the formula for their areas here. We know that for both of these triangles that their area equals 1/2 times their bases, which are 3, times their heights, which are 9. Question 6. This is by far the hardest question we've done all day. It says, here is an octagon. A, while estimating the area of the octagon, Lynn reasoned that it must be less than 100 square inches. Do you agree? Explain your reasoning. And B, find the exact area of the octagon. Show your reasoning. Okay, I really want to challenge you guys to try this one on your own. I'll give you a hint for B. You're going to want to split the octagon into different shapes. All right, pause, try it all on your own. Look up when you're ready. Okay, I'm going to start by reviewing the answer to A. I'm actually going to write it up here. So A, she says that it has to be less than 100 square inches. If I add 3 and 4 and 3 on each side, I get a total of 10. 10 on this side, 10 on this side. So if instead of being an octagon, if this were, and I'm just going to use dotted lines to show that it's not real, if this were a square measuring 10 by 10, then the area would be exactly 100. But I can tell, just like Lynn can tell, that that octagon fits inside of that square, which means that its area is smaller. So we're going to say yes. Why? Because the area of the square outside the octagon is 100. The octagon is smaller. And let me just make this a smaller font so that it's not overlapping and you can read it all. Okay, we also showed our reasoning through our drawing. Now B is where we get really, really tough. This is where I'm going to use my line tool to really show you guys how to break this up into different shapes. Okay, I'm going to start by breaking it up so that I have a rectangle. And then I'm going to label the sides of my rectangle. I know that this side is 4 because it's right here. I know that this side is 10. So overall, 10 times 4 gives me 40. So I know that the area of just this rectangle is 40. I'm going to circle the areas of my smaller shapes. Then up here, I know that I can make 2 small triangles and 1 rectangle. The area of this rectangle is 4 times 3 because I have a 4 up here and a 3 over here. 4 times 3 is 12. So the area of my smaller rectangle is 12. Now the area of this triangle is going to be 1/2 base times height. The base is 3. The height is 3. So let's show our work for that down here. Area of the triangle equals 1/2. And let's draw a little triangle next to our A so we remember that this is for the triangle only. 1/2 base is 3 times height is 3. So 3 times 3 is 9. 9 is an odd number, so I can't really divide it by 2, which means I'm going to end up with either a decimal or a fraction here. 9 divided by 2 is 4.5. So the area of my small triangle, and again, I'm going to circle it, is 4.5. And that's going to be true for every small triangle in my shape. So circle our area 4.5. And then up here, once again, because it's the same dimensions on my triangle, base of height, base of 3, height of 3, on this side, I'm also going to have an area of 4.5. Sorry, got a lot going on here. I'm deleting the wrong things on accident. So over here, we're going to have 4.5. But I'm missing part of my shape. I'm missing my bottom part. I think before I go any further, let's just see what all of this added together is. The area of the whole top segment. So I'm going to say area of the top is 4.5 plus 4.5 plus 12. You can use a calculator if you want, or we can do this mentally. 4.5 plus 4.5 is 9, plus 12 is going to end up being 21. So now I know the area of the top is 21, the area of the middle is 40. How do I find the area of the whole thing? I need to take that 21. So I'm going to put here area of the whole thing. Area of the whole. 21 times 2, because I have a top and a bottom that are identical, plus 40. 21 times 2 is 42, plus 40 is 82. So the exact area of this whole octagon should be 82. If you got that correct, you need to give yourself a pat on the back right now, because that was a really, really challenging problem. Okay, the rest of class today is going to be you and your exit ticket. It is for a grade. Be sure you are doing your best.